the sign test for paired samples using non-numerical data. Now this is the only test that we can use because of our non-numerical data. These two are not an option. We have to use the paired sample sign test when we're looking at data like this. So in this example, we've got 15 girls and we've got their grades for the oral examination, the spoken one, and the written examination. And we're using a sign test, and that's a paired sample sign test because we have pairs of data values, and we're looking for a difference in the grades between the two exams. Now this is a single table. It may appear as though there are two separate tables here, but there's no space at the end to continue, so this is student number 8 and this is number 9 and 10 and so on. So this effectively goes on the end of this to create a single table. And we're going to use a 2% significance level. It's a two-tailed test because we're looking for a difference in the grades between the oral and the written exam. And because this is a two-tailed test, we can do oral minus written or written minus the oral exam. It doesn't make any difference. You can tell from the signs that I've put here, I've done the oral minus the written. So this grade is higher than this one, a plus sign. This one's higher than this, a plus. This one is lower than this, a minus. These two are the same, they're crossed out. So from the 15 pairs of data values, 2 have been crossed out. So n is equal to 13. Our H0 and H1 in terms of the population median difference. So this was the order that I've used. There were 10 plus signs and 3 minuses. 2 were crossed out, we're not going to include those. The binomial tables we go to, 10 plus 3 is 13. So n is 13. This is always 0.5 when we're working with the sign test. A 2% significance level, because it's a two-tailed test, we have to split this. We're working out the probability that x is less than or equal to the test statistic, which is 3. So going to the tables, n is 13, p is 0.5, less than or equal to 3, 0.0461. And 0.0461 is greater than 0.01 from here. So we're going to accept H0. And the conclusion in context. So when writing your hypotheses, you can either word them like this, population median difference equals 0, or you can use this shorthand version here. And this is a Greek letter. Yeah, it's not n.